we would like to take the opportunity to introduce our guests who are present here today. 首先，让我们欢迎科技部张善政部长，经济部杜子君次长，科技部林依萍次长，经济部工业局吴明基局长。 经济部工业局吕正清副组长，欢迎吕副组长。科技部产学及园区业务司邱球慧司长。科技部新竹科学工业园区杜启祥局长。资策会柯宪堂处长。ARM 行销长 Chief Marketing Officer of ARM Mr. Ian Drew，welcome。 ARM 处理器部门负责人 Deputy General Manager of CPU Mr. Noel Hurley。ARM 大中华区总裁 Greater China President of ARM Mr. Alan Wu 吴昂雄先生。非常欢迎，也谢谢各位贵宾的莅临。我们接下来首先就先请 Mr. Ian Drew 来跟我们针对行动市场、互联网、伺服器等等市场来分享 ARM 对于市场趋势的观察。 To kick off the press conference today, please join me in welcoming Mr. Ian Drew to share with us ARM's market insight.
Thank you very much indeed for coming on such an auspicious day. I've been coming to Taiwan Computex for most of the last 20 years. I've seen this show grow. I've been coming with ARM for the last 8 years. I've seen how Taiwan, what's gone on in Asia and what's gone on in ARM have really seen a growth in the industry never seen before. People look at the PC industry and go, huge growth there 10 years ago. But this show really has become phones and tablets, and how the uniqueness of Taiwan and the uniqueness of Asia really brings a world dominance in this place. And I think for the last 8 years, we've been having a press conference here, and it's such an honour to talk to all of you. So today, let's go the right way. Today I wanted to talk to you about how things change. I gave a keynote last year about ecosystems, and how the importance of ecosystems in this new business model for the 21st century really defines how companies and countries grow. I talked about opportunities, both for Taiwan and Asia, but I also talked about opportunities for the industry as well. So I'd like to build on that today. I'd like to build on it in a couple of areas. The first thing I wanted to talk about was IoT, Internet of Things. It's a very nice marketing buzzword. But if you look at it, we already have nearly 1 billion connected devices. Motors, cars, washing machines, watches, wearable devices, medical devices. There are over 4,000 semiconductor devices targeting this IoT and wearable. And it really depends on how you look at it as to that number. You compare that to 5 years ago, that number would have probably been in the hundreds. This expansive growth that we've seen is probably the start of a revolution, not the end. And I want to explain how that's going to work. I keep pushing the wrong button. When I first came here, we talked about segmentation. And people said, what sort of laptop should I build? Should I build a low-end laptop, a mid-range laptop, or a high-end laptop? And we said, what you should look at is this huge category that's going to come about, and there won't be segmentation, there'll be hyper-segmentation, and you'll be defining what the customer really wants, not what people want to go build. And we started to see that take shape. So as we look about how things work. You'll see when there's starts of new existing categories, what people will do is take the existing SoCs or CPUs and go, how can I repurpose some of these? Then they'll start reshaping those CPUs to customize for a market. Then when it goes into volume, you'll see huge segmentation happen. Number of different memory sizes, I/O, graphics, and everything else that goes with it. So you won't just get mid-range, low-end, or high-end of anything. You'll get huge segmentation and a roadmap that covers what customers really want, and you'll get customization and personalization of the products. Where are we on some of this? We're seeing some of it in IoT and wearables. New categories being created. Watches, medical devices, and the like. If you look into the customization, you're starting to see servers and infrastructure, purpose-built products really coming to market for that now. And then you go into the far end, hyper-segmentation on phones and tablets. You're really starting to get phones that go from very low tens of dollars up to thousands and thousands of dollars. This segmentation is really happening, and so it's very difficult now to go, this is a high-end phone, this is a high-end tablet. Where does the boundary lie? Is it price? Is it memory size? Is it size of CPU? We're seeing huge segmentation happening in the industry, and this is really about consumers being able to buy what they want, when they want, how they want, at the price they want. That's the change that's happened in this industry. No longer will you have one or two companies going, this is what the consumer should buy. We are now seeing a revolution on what the consumer really wants, and that's leading to huge growth in the industry. But that only happens when you have an ecosystem of partners that can really adapt very quickly. And this is where Taiwan comes in. The adaptation of the Taiwanese industry to really take use of this new infrastructure that's put in place really enables its growth. That's the adaptation, that's the speed of change that we're seeing, and that's what's really been humbling over the last 8 years to see that growth. I talked last year about data centers and servers. I said this is the year that you'll see people actually using it. I still think that will happen. In the second half of this year, you will see major announcements about data center usage, people putting in ARM-based servers. Why are they doing that? Low power in the data center is one of the most important things we can do. In the next few years, there will be more CO2 emissions coming out of data centers than there will off aeroplanes. We need to control energy usage through infrastructure. We need to have low power devices in place. That is what we bring to this industry, and we will enable that through multiple players. We were looking for examples of how the industry is going to change. It's one of my favourites. NASA wants to put small data centres in space on satellites. It used to cost $100 million to do that. Very expensive, high power, high performance. We're now working with a company that will be ARM-based, low power, high performance, at the right price point. We are now no longer tethered just to Earth. You're seeing ARM servers in space. Very, very exciting. But when you look at really what's changed over the last 8 years, I remember talking about TVs and set-top boxes as two different categories. I remember talking about tablets and consumer devices as different categories. We are now seeing huge movement in media. TVs, phones, tablets, all playing different media content. And you were seeing huge growth in the industry around where video is being consumed. The amount of the growth in video across the internet is staggering over the next few years. That will drive new infrastructure, drive new usage models and new business models in this industry. We need to make sure that we adapt and have the right product at the right price. But the good news is this hyper-segmentation can make use of that. Watches. We've seen a lot of people talk about watches recently. The watch on the left is built on an open source operating system, uses an A-class high-end processor, has a modem in there, looks very similar to a watch, to a phone. On the right is an embedded processor, using an embedded operating system, still a smartwatch, will do a lot of the things but won't be a phone. What you're seeing now is this growth in this industry where you pick the right product for the right design that you want. If you want a high-end phone, you can have that hyper-segmented high-end device. If you want an embedded phone, embedded watch, you can do that. You take this industry of hyper-segmentation and pick the right part, the right product. And you can only do that when the industry is moving very quickly and you have diversity in this industry. And that's what Taiwan brings for us. You look at housing. People say, housing's great, but what are you really doing about saving money? Design in a New York office and apartment buildings. Designs using embedded controllers from ARM with Wi-Fi, saving up to 15% of the electricity now. You're starting to see these embedded controllers appear, not just in watches, but really deeply embedded devices. We're starting to see washing machines and motors appear. You're starting to see motor control on big mining plants appear. All of these are connected devices. We see billions and billions of opportunities going forward. Not just for the smart device with a high-end OS, but billions of embedded devices in everyday usage as well. But all of that needs a starting point. And this is where I left it last year. All of it needs a starting point, which is the ecosystem. Nothing can be done without partnerships. Nothing can be done without friends in the industry trusting each other and moving forward, both in a software, a hardware, tools, operating systems, fabs, that whole industry working together to create an ecosystem that you can build on. There's thousands of partners in our ecosystem. There's tens of thousands of SoCs, and there's millions of developers. A lot of that growth is coming because of what we've done in this room. A lot of that growth has been built on business ideas that are decided in this room. So before I hand over to Noel, I just wanted to say thank you for that. I see the last 8 years as huge growth, but I actually see the future of IoT, the future of content, the future of servers really happening in this room and being decided now for the next 8 years. I think it'll be a lot more exciting. With that, I'd like to hand over to Noel, and I'll be back in a bit. Thank you very much.
Thank you very much, Mr. Ian Zhu. And now please join me in welcoming the Deputy General Manager of CPU at ARM, Mr. Noel Hurley. 我们欢迎 ARM 处理器部门的负责人 Mr. Noel Hurley.
Thank you very much. It's a pleasure to be here. So following on from what Ian was talking about in terms of the evolution of products and the evolutionary stages that different products go through from initial concept all the way through to, I guess, on the more mature side where you have this hyper-segmentation that happens in the marketplace. What I wanted to talk about was, okay, so partly what is ARM doing in this field, and also expanding a little bit on some of those ideas. So, firstly, with ARM, and you can see from the timeline at the back of the room, right? So ARM's been around for 20 years, and over that time, we've built up a tremendous broad range of processors. And often, processing is the starting point for many new products. What type of processing do I want, whether it's from microprocessor or in terms of graphics for user interfaces, those types of things. And so from our side, we've built up over time a tremendous range of application processors in the mobile space, but also looking into the embedded marketplace as we start to look at things like IoT, a tremendous range of embedded processors that go alongside that. And matching that, then graphics processors as well that have built up over the same period. And the reason for doing this is about, to Ian's point, is about making sure that there is the right product for our semiconductor partners, so they have the right type of processing necessary for all the different markets that they wish to go into. And so on the far left-hand side, where we're talking about connected sensors and IoT, where on this slide, actually, it says, measured in microwatts. This day, actually, it's measured in nanowatts. That's the measure that we're talking about in terms of the power consumption for these types of devices, so that you can have many years of battery life from these devices, all the way through the different segmentations, as right the way up into the servers and enterprise infrastructure type markets, where 10 watts-ish is what we're talking about in terms of a measure. So you can see from that there is a huge range of diversity required to address all of those markets. And having an architecture that connects them all in this day and age is becoming critically important, so that you can leverage ecosystems, you can leverage development done by different parts of the industry and create one consistent flow all the way from sensors right the way up into data centers and cloud services. And of course, in the center of this, in the center of the technology world today, is the mobile and the huge growth of the mobile marketplace. We're predicting there'll be more than 1.3 billion smartphones shipped this year. So that's a tremendous market. Now, one of the consequences of this one market is that you have a fantastic economic base to then develop technology and move that technology into other areas. So we see some of the investments that have been made into mobile. You see them starting to appear in smart TVs, for example. Many of, Bluetooth LE, the low power Bluetooth or Bluetooth Smart, it starts off in the mobile space and then moves on. So the mobile phone, because of its volume and because of the economics around the mobile phone, is a tremendous platform for developing and starting innovation. And so when you have a new product range or a new product category coming into the market, you often see mobile phone technologies being in that first generation of product that comes to the marketplace. And that's what we're seeing today in the whole wearables market. The other thing about this expansive mobile space is it also creates a fantastic ecosystem. Today there are over 1 million apps developed on the ARM processor. So again, you have this very large economic base. It attracts software developers, it attracts an ecosystem into it. And then that can be leveraged into other markets, into new segments. And so when we look at IoT and we look at wearables, even though this is a very young market, we are starting to see some segmentation already. we go from everything from Fitbits, which is essentially a sensor on your wrist, measuring activity during the day, all the way up to, you know, some really quite sophisticated, and I know in the back of the room, they've got the Oakley goggles, you know, which are for skiing, and they give you your GPS location, and they give you effectively a heads-up display-like experience whilst skiing, for example, which is a very high-end product. So we're already in the wearables space, starting to see a level of segmentation, and therefore, to address this market, you also need to have the right type of processing and semiconductor technology to match that segmentation, so that if I've got a band on my wrist, it is working for weeks, not days, etc. And when I'm looking for something that's, you know, more visually appealing, you know, like the Oakley goggles, is that it has enough performance to be able to do the task that it promises to do. So you're starting to see that segmentation. Now, we often focus on A-class cores because that's, you know, the heart of the mobile phone is the Cortex-M processors. But it's interesting to note that in IoT and in wearables, we're starting to see a growing importance in the Cortex-M, or the little smaller, ultra-low power, very high efficiency cores. And this is a market that has been growing rapidly alongside the mobile space. And so what I want to do is spend a little bit of time just talking a little bit about the M-class family. What I'm showing here from Freescale, just to give you an idea, and this is to scale. This is one of the smallest M-class processors on the marketplace today. It's 2 millimeters by 1.6 millimeters. That is not a die, that is a packaged part. And that is to scale on a golf ball, just to give you an idea of how small these processors can be. They are like dust, you can scatter them around, hardly notice them. And that's 48 megahertz, it's got a processor in there, it's got flash in there, it's got ROM in there, so this is a functioning processor. So that's the kind of device that we're talking about, that can be put into thermostats, that can be put into every single light bulb that you see around you. So you can see the potential for growth is huge. And in the M-class family, like the mobile space, there is also a huge growing ecosystem of both semiconductor partners who are making that type of silicon, but also tools developers, software and operating system companies. And as you can see here, so far in the marketplace, there has been 16 billion Cortex-M based processors shipped into this embedded space. So likewise, it's a huge market and a huge growing economy around these products. And what people are trying to do is on the left-hand side there's a great variety of applications that they're trying to address. A huge variety of applications. And to bridge that gap, companies like ourselves and Arduino and Electric Imp and Raspberry Pi and Beagle and these guys, what it's about is trying to put together a technology framework that allows developers to start to develop and invest from a technology perspective into these products, where the vision really is to get millions of developers developing around these cores. And so to do that, within ARM we have an embed platform that we're putting together, which is an operating system and a set of tools and software that is all open source, so that you can start to realize that vision of getting millions of developers with a very little initial cash outlay to start developing their product and start to bring their ideas to fruition and making them real in the market. Alongside the usual software, we're also putting together some simple software stacks as well, so that you can get internet connectivity very easily and develop your product around that. So, from ARM's perspective, as we look forward, we're well known for the mobile space, but as we move forward, the growth of our company, and we see the growth of many of our semiconductor partners, is actually going to be around embedded. It's going to be around servicing this part of the marketplace, servicing those millions of developers with all the ideas that they have, and pushing those into new categories, into both IoT and wearables. And so, with that, I'd like to invite Drew back up onto the stage to close out. Okay, I'll stay with you.
So, there was one announcement we wanted to make, and it's quite a big one for ARM. We don't do this every year, and so we want to actually announce our first design centre in Asia, and it will be in Taiwan.
是的，ARM宣布在台湾要成立世界级的 CPU 设计中心。现在就有请科技部张善政部长以及经济部杜子君次长以及 Mr. Alan Wu 一同上台来宣告 CPU 设计中心在台湾正式成立。We would like to invite the Minister of Science and Technology as well as Deputy Minister of Economic Affairs and Mr. Alan Wu to come up to co-announce the establishment of the CPU Design Center in Taiwan. And first of all, we would like to ask you to put on a big smile for our cameras. 我们请几位贵宾，让我们的摄影师捕捉我们今天相当难得可贵的画面。And we will count down from 3 to 1 to officially launch the announcement. 3, 2, 1. ARM 在此正式宣布，将在亚洲成立 CPU 设计中心，立足于台湾。这是 ARM 首座在亚洲台湾的 CPU 设计中心。我们将会负责 ARM Cortex-M 系列处理器产品的设计、验证、锁定物联网、穿戴式的装置以及嵌入式的应用市场。Thank you very much, and we would like to ask all the guests, please put your thumbs up for the CPU Design Center that is in Asia and also in Taiwan. 我们也请现场的媒体朋友再一次帮我们捕捉这一次的画面，真的是相当令人期待的消息。我们希望能够让资源聚焦在台湾，创新放眼全世界，为台湾也为 ARM 下一个里程碑，也就是1000亿的里程碑，一起加油打气。我们是不是再一次掌声 ？Thank you once again. 也请张部长以及杜次长帮我们简单的说几句话。We would like to ask also Minister Zhang of Science and Technology as well as Deputy Minister Du of the Ministry of Economic Affairs to give us a few words.
经济部杜次长，还有 ARM 的长官们，还有媒体嘉宾，大家午安。我想看到科技部跟经济部一起在台上啊，就知道说今天这个 ARM 的这个设计中心在台湾啊。真的是把台湾过去多年的发展，从最上游学校里面培养 IC 设计人才，到中下游产业发展都串在一起。我想ARM到台湾来这边设计这个设计中心啊，验证说过去台湾这么多年，早年在学校里面从很早以前的什么系导计划培养 IC 人才，终于啊让国际上面见识到说，台湾其实在 IC 设计上面最大的宝库就是我们的人才。当然要有中下游的产业配合，所以我们整个供应链，我想等一下陆市长可以讲一下，可以把这些最好的设计理念落实到实际产品上面。所以今天ARM到这边来设立这个台湾的这个CPU 设计中心呢，我想是台湾过去多年把这个我们说10年磨一剑啊。从上游到下游的这个整个 CPU 设计这个专业落实到我们每天日常生活这种将来物联网也好，穿戴式装置也好，未来的社会里面最重要的这些装置都会里面有 ARM 的这些装置，里面呢更细的看下去，有台湾的人才，有台湾的产业，所以在这边我们要恭喜ARM，来恭喜我们自己，谢谢。
Thank you, Minister Zhang, for highlighting the talent in Taiwan as well as how the CPU Design Center connects upstream and downstream of the IT industry in Taiwan. And now we'll turn the floor over to Deputy Minister Du of Economic Affairs.
张部长，所有那个 ARM 的主管，在座的媒体，女士先生，大家午安，大家好。今天非常高兴能够来出席 ARM 正式宣布在台湾设立了亚洲第一个，也是它全球第4个CPU 中央处理器的设计中心。那这个是台湾有机会在几个竞争国家之中呢，能够被 ARM 来选择作为它这样的一个重要的中央处理器的一个设计中心呢，那我们觉得非常的高兴。那我想除了刚刚张部长提到过去我们长期在学术界跟人才培训之外呢 ，ARM 过去2-3年在台湾的合作，包括我们工业局跟他合作在人才培训跟整个人才的这个跟 ARM 的架构的这个验证制度呢，我想让 ARM 能够充分的理解到台湾除了人才非常优秀以外，另外在于这个中下游，包括各位看到未来在 IoT 几乎所有的物品上面都有机会出现这 ARM 的产品。我们在国内的这样的一个完整的一个供应链制度，那还有就是我们不断提到的台湾在对于智慧财产权的保护呢，可以说是非常的完善。我相信这些都是 ARM 选择在台湾设立 CPU 设计中心。我们也希望在这样的里程碑之下呢。让台湾的企业有机会跟 ARM 能够持续的在未来的一些各种可能的领域呢来从事合作。我们希望透过更紧密的一个合作方式，让在未来的这个市场发展上，除了在里面有 ARM 的这样的一个 CPU 存在，我相信它的周遭的所有的设计、应用跟产品呢，都会有台湾企业的这个合作的成果。那么一起的努力，来为未来的世界能够创造一个更便利、对生活更智慧的环境。预祝ARM 这个 CPU 处理那个设计中心呢，在台湾工作顺利，也希望 ARM 持续的能够在台湾能够加码投资，所有的需要协助的工作，经济部都愿意来跟 ARM 能充分的来支援，让它把台湾作为一个在研发过程中不可或缺的重要的合作伙伴。谢谢大家，谢谢。
Thank you, Deputy Minister Du。再一次谢谢科技部的张部长以及经济部杜次长。我们非常感谢2位的贵宾今天的莅临。我们再一次谢谢部长以及次长今天特别来出席我们 ARM Computex 的记者会，给我们加油打气。Thank you once again to Minister Zhang of Science and Technology as well as Deputy Minister Du of the Ministry of Economic Affairs. Thank you so much for your participation. Ladies and gentlemen, we will now open up the floor for questions and answers. 各位贵宾，我们接下来将开放我们的 Q&A 的时间。我们也跟各位媒体朋友说明一下，我们待会主要 Q&A 的时候会以英文进行。不过各位台湾的媒体朋友，如果需要以中文提问的话，我们 ARM 的同仁以及我都会在场协助各位。So ladies and gentlemen, we will conduct the Q&A mainly in English.
Not bad yourself. Not bad. Splendid. How many people do you expect to have working in this new facility, and what sort of work will they be doing?
So to start with, on the, I'll answer the second part first, which is what sort of work will they be doing. We will be doing CPU design here. We'll be doing CPU design initially targeting IoT and wearables segment.
The M-class cores.
M-class cores. So next generation of M-class cores is what we would expect, is what we will be doing in this design center. In terms of how many people will we will, CPU design teams tend to start around 40 to 50, and then it'll depend on how we ramp. But one of the important considerations for Taiwan, actually one of the important considerations for opening up our CPU design center is to look at finding a talent pool that has the ability to be able to scale, and that was important to us. Right now we have CPU designs done in Cambridge, in Austin, Texas, and in Sofia in the south of France. So this will be the 4th CPU design center that we have within ARM.
And I think it's fair to say we're not announcing this and it's starting in 2 years' time. We are hiring people now. It's not an intention, it is a we are doing this.
Thank you, and we will take our next question.
I have 2 questions. I'm a reporter from Union TV. First 2 questions. The first question is, what advantage does it offer you to build your first Asia center in Taiwan? What kind of advantage does Taiwan bring to your company? And second question is, we're seeing a lot of growing trend of mobile, and are you seeing a lot of new trends in the future market?
You do the first one, I'll do the second one.
Okay. So the first question was why Taiwan? We see, as I said in the earlier question, one of the considerations was finding a talent pool where there is CPU design done. And when we look around the world, what we see within Taiwan is there is both a talent pool, but also with the research institutes and some of the work that they're doing as well, there is also the capability to grow engineers, as it were, over time as well. Because for us, it's about not just having a centre, but then having a centre that we can grow and scale. So that was one area in terms of talent. The other area is also around regional proximity as well. So we have a lot of our semiconductor partners here, a lot of very significant semiconductor partners here. Also, you've obviously got the likes of the TSMC and the classic foundries in this region as well. So putting a design centre here close to much of the semiconductor expertise also makes a lot of sense and gives us a local base as well to grow from.
And to answer your second part of your first question, the mobile growth we see continuing, innovation continuing over a long period of time still. If you look over generations of mobile phones, so people tend to change their phone every 18 months, 2 years. Look back over the last 18 months what's happened. You're seeing big. LITTLE coming out where there just used to be multi-core, generations before that was single core. If you look at how much sensors are in your phones, a couple of years ago there were 1 or 2, now you're talking about 8, 9, 10, 11, 12 sensors. You look at screen size and resolution on that, you're looking at battery life, you're talking different radios in there. And then you scale that from low tens of dollars to thousands of dollars in price points. You're looking at different ways in which you're using your phone, you're looking at different forms of security going in there. We see that innovation continuing over the next 4, 5, 6, 7 generations of phones. So it's not going to stop, in fact it's going to continue and increase in pace over the next few years. Add to that different screen sizes, and as we talked about segmentation before, what's the difference between a low-end tablet that's got a 3G radio and a phone these days with a large screen on it, very little? You're seeing this segmentation growing in all sorts of different areas. We think consumers will get a lot more over the next few years from innovation in phones and tablets.
2 more questions, sorry. One is that how much investment, what kind of investment are we looking at? Like a number. As the second question is...
Again, investment in the Taiwan?
Yeah, in Taiwan second. And the second question would be, what do you see in the wearable device in the future? We're talking about mobile, and then we're seeing a lot of new trends about the wearable devices. What's your view on that?
Again, you do the first one, I'll do the second.
So in terms of investment, I'm not going to give you a dollar value because actually I'm not sure that it makes a great deal of sense to do that. The investment is, as I say, we currently have 3 CPU design centres. This will be our 4th, and we will grow. This will become the hub, essentially, for this greater China region.
And will be used worldwide as well.
Oh yeah, these cores will be going into products worldwide. Yeah.
And if you look at wearables, I think there's two different classes of wearables. There will be the wearables with a screen that you may have a high-end operating system or even a low-end operating system, but something that has got a UI on it. It needs a bit of graphics and memory, and you'll be able to interface with it. And then you'll have the wearable that is no screen, but will interface probably to a phone that will allow you to go and monitor and measure things and give you direct feedback. We see lower power devices coming out, different types of radios coming out, how content is used in that space, who really controls that content will have to be thought through as an ecosystem. We're seeing higher performance devices going into some of these wearables because they'll need some rich content, but it'll be different power models, so you'll only need it in short burst modes, whereas phones you'll need it for longer. You're seeing big little going in there at the very high end. So lots of different things coming out over the next few years in wearables.
Yeah. I would say as well is that the wearables is not just about consumer entertainment products or those types of products, but we're also seeing trends where the professional marketplace is also picking up wearables. They have tremendous opportunity in areas of security. They have tremendous opportunities, and I mean by that by security guards and securing the premises, and also in things like logistics buildings where you have a workforce that are picking and packing, those types of things. These types of wearable devices also have a very strong professional opportunity, as well as what you often see, which is the consumer type product.
And I'd add the final one there is medical.
Medical as well.
Clearly medical is becoming a large area as well, so both from a personal medical hobbyist almost on your Fitbit to a really high medical device that will track me and my heart monitor and everything on a very in-depth basis. So we're seeing that huge range of possibilities coming out.
Thank you, and we will take the next question.
I think there's an Australian who wants to ask me about cricket at the back.
All right, so I think I'll turn the floor over to our Australian reporter.
No, I don't, honestly, Ian.
I don't want to embarrass you any further, frankly. I just want to, in advance, commiserate England's poor performance in the World Cup. That's all. I did have a question. It was already asked and answered, so you're ahead of the curve on that one.
Okay, thank you.
Thank you, and let's take the next question.
Hi, my name is Adam Shah from IDG News. You did talk about your plans for wearables and so on, but what chips are you actually developing in the labs at this time? Or what chips are you looking to develop? And what type of wearable devices will they go into?
So, I'll start. The vast amount of wearables that you'll find on the market now are ARM-based. So we don't build chips, but we design IP that goes in it. The IP that we're developing in labs goes from very low-end, low power, as Noel was talking about, nanowatts technology, really the smallest core you can get, the most energy efficient core you can get. We're talking to companies of how you link radios into that and making sure that that all works together, all the way through to some of the technologies around big little that we talked about in phones. How do you scale that into wearable devices as well? So the scaling, so we hit all parts of that segmentation, from the low end all the way through to the high end. And again, it depends on what you want to run on it, whether you want to run a rich operating system, a Linux or an Android or something, or an RTOS at the very deep low end.
Just to supplement that, so when we're designing next generation CPUs, obviously the types of tasks that the market is demanding is clearly forefront in our minds as to when we're designing the next cores. So when I look at a trend like wearables, and trends like sensor hubs that you're starting to see in mobile, and many of the wearable devices are sensor hubs with an applications processor. When I look at the sensor hubs, the types of tasks that you're looking at is things like DSP functionality, where you are trying to read data off sensors and pre-process that data in a very energy efficient way. So what we're seeing is things, so energy management within the applications process is becoming increasingly important. And then down as close to the sensor as possible is doing much more of the DSP and maths on the data, so that you can run, you can keep most of the system off. You're only sending a minimal amount of data upstream to be processed, those types of things. So in terms of thinking about how we're developing our processes going forward, obviously things like DSP functionality is going to be important for sensor data, and that energy management. And then at the extreme end, at the very top end, is things like thermal management, when you're trying to push the limits in terms of performance.
Thank you. And I think we have a question here.
Commercial Times Yvonne. The question is about Intel and Rockchip. Everybody knows the news being announced. Sorry, it's from my mouth, but I have to translate. So what's the impact to the current market share? Because apparently ARM has been quite in the leading in terms of market share. Would that be in the long-term potential a threat to shifting the percentage of market share? That's number one. And number two, will change the Intel kind of relationship from might be compete with ARM, because Rockchip apparently is ARM's licensee. So 2 questions.
Very good question. It was announced last week, Intel and Rockchip doing some work together. It wasn't fully announced exactly what they were doing, so like all of us, we can kind of guess. From an ARM perspective, Rockchip is a great partner of ours, and continues to be a great partner of ours. And you see the growth, especially in China and Taiwan and Asia, of phones and tablets. And Rockchip's been at some of the centre of that, and will continue to be in the centre of that, and will continue to be a very strong ARM partner. For ARM, we see this market growing, and almost Intel starting to follow what we've started to do in some of these areas. Whereas 10 years ago people said Intel was leading, now they're starting to follow some of our ideas. I think we continue to grow, and I think we continue to compete. This doesn't really change the dynamics of how we're competing together. Effectively, it says that Intel would like some of that tablet market, but we've known that for a while. Good question.
I think it just endorses that partnership is the way forward.
And it doesn't change our relationship with Intel one little bit.
More importantly, it doesn't change our relationship with Rockchip.
Thank you. And I think we have a question in the back.
Jim McGregor from Curious Research. Hi guys.
Hello, Jim.
Quick question for you. Obviously, as you target different markets, every market has very complementary technology, especially as you're going after embedded, whether it's energy harvesting or whatever. So can you kind of highlight, is ARM going to be developing any of those complementary technologies also at this design center? Or do you have some key partners also in Asia that you think are going to complement that?
We only lightly touched on what we were doing with things like embed today. But you're right, yes, we are working not just on the CPUs, but there are activities like embed where you put the OS and the software framework around the CPUs. We already today ship little subsystems with the cores as well. So that allows a semiconductor partner to get up to speed very quickly, and the framework is such that then our semiconductor partners customer as well is able to then build on that framework. We made an announcement about buying a company called SensorNode. That extends embed up using 6LoWPAN up into the IoT space. So now there is both client-end software as well as cloud-end software. So from an OEM's perspective, by buying into ARM and embed, I have a quick route for connecting whatever device it is all the way up into a cloud service.
I would add into that, if you look at where apps are being developed 10 years ago, a lot of it would have been America and Europe somewhere. You look at where the apps growth is of the companies, a lot of it's happening in Asia, and that IoT is happening in Asia. And what you want to do is connect your design center with some of those leading edge apps guys to go, this is what we need in a few years' time. So it's logical putting it here as well. So the ecosystem is mature enough that we can put a design center here, and they can talk around Asia and go, this is what's really required.
Even on things like, you look at social media apps. I think social media apps are probably more advanced in this region than they are in the US in many ways. So there is a huge amount of software evolution happening in this space as well, and innovation around social media, as well as around hardware and classic markets at China and Taiwan. So I think there's an increasing amount of software innovation that's happening in this region as well.
Okay.
Thank you, and let's take the next question. Are there any other questions? 现场媒体朋友还有没有任何其他的问题 ？Yes, we have one in the back.
Just had a question, general kind of market question of wearables. Some say it's kind of it's a gold rush in the times, but what's really important for wearables to actually succeed? Invisibility. How important is invisibility and battery life?
Well, I think if you're going to wear something, charging it up every night is probably not going to make it as ergonomically friendly as you really want. I mean, you're going to have days, weeks, months of battery life in whatever you wear. It needs to connect correctly. You need to understand where your data is going and how it's managed. You need to be able to be reassured that it's actually on and working and not died, so there has to be some interaction with it as well. So there's lots of different things that I think we're at the start of a wearables revolution. And I think like phones were 6, 7, 8 years ago, somebody will blossom out and go, oh, that's the right thing. And having an ecosystem of lots of people trying will mean there's a growth in this industry of people trying lots of different things, and 1 or 2 of them will work and 1 or 2 of them won't, and you'll grow and learn as you go along. Do I think there's this golden thing at the moment? People know exactly what it is, no. But I think lots of people are trying, and I think it will become very successful. Size, power, connectivity, data management all become important.
And just add to that as well. So in terms of power management, it's absolutely critical, and it's critical not just for the charging time that Ian talks about, but you're quite right in terms of invisibility. The battery is probably one of the heaviest components within the system. So if you're going to have anything that's wearable, say on the medical side where you've got something attached to the skin, actually the weight and profile of the product is really important as well. So if I can perform the task in hand in a very, very, very low power way, then that means I've got a smaller, lighter battery that makes the product more comfortable to wear. And that's important. And if you talk to the medical guys, one of the biggest issues that they have in many hospitals is patients ripping things out because they're cranky, they're tired, they're ill, and something's uncomfortable, and they pull it out or tear it off. On the very early studies of plasters, vital signs monitoring plasters, one of the big issues was they were big and heavy, so patients just took them off. So that it has to be imperceptible. It's on, but you can't feel it. And for that, it needs to be super lightweight, and very light profile, and the battery is one of the big heavy components. So power consumption is not just about charging, but also about comfort as well. So there's many ramifications to reducing battery life.